righty, guys. Do you see this?
Yeah.
Let's get our terminology. Step 1, a minor arc. I'd like you to trace B to C. This is a recap from your preview notes. We're in your reference booklet, dear. Reference booklet, trace B to C. Go like that, 2 letters. It's 2 letters. It is less than 180. Excellent. Major arc means you go the long way around the circle. So you go like this. You start at B, sweep around through D, and end at C. That is the arc BDC. That is bigger than 180 degrees. Okay, this red arc can be named using another order of letters. I'd like you to do your best in 10 seconds to figure out what's another way to name that arc. Yourself. Okay, tell neighbor, what do you think it is? Go. You're right. You just go around the other way. CDB. That's the exact same arc. It's just another name. That's the difference between major and minor. Minor, 2 letters. Major, 3 letters. You see 2 arcs. So the short letters, long way. 2 letters, short way. 3 letters, long way. 2 letters, what? 3 letters, what? So if I want to go the short way around the circle, how many letters do I use? If I want to go the long way, 3. Okay, keep that in mind. That's important for notation. Semicircles. Whenever you have a diameter, you do 3 things with that diameter. Thing number 1, you trace it. Thing number 2, you stretch it out. Does that even show up? It actually does. And then you sweep the 180. Trace, stretch, sweep. Elbows straight out. Elbows out, guys. Elbows out. That's not a diameter. Your elbows make a diameter. Elbows out, kiddo. There you go. What do we do with diameters? We trace them, stretch them out, and sweep 180. So diameters. Trace, stretch. Do it again. Say it with me. Say diameters. Trace, stretch, sweep. Watch out for diameters. They're very commonly overlooked. Ready? On the right-hand side, you are looking at, we name semicircles using 3 letters, folks. Thank you, Jacob, for showing me the blank semicircles. So we would name this semicircle, this blue one. Thank you. Yes, we could go EJG. EJG, or we could call that EHG. And if I want to say the measure of, I put a little m in front of it, and I would say that equals exactly 180 degrees. Yes, ma'am. With an angle. So notation is everything in geometry. Okay, don't move. Got it. On the right-hand side, count how many circles do you have on the right-hand side?
1, 2, 7.
By the end, you're going to know 10 distinct types of angles in circles, 7 of them. Today, I'm only focused mainly on one, and I'll introduce you to the second one, but not focused on it. Okay, the most important one today is called the central angle. Central, center. Say those two words. Central, center. Say it again. Central, center. A central angle, make a center. Is it? There's a lot of allergies going around. Yeah. Okay. Ready? Okay. That's the center. So this is called a central angle. Think pizza slice or pie slice or whatever that thinks. Okay. And we learned last night that this angle right here on the side connected to the center, that central angle has the exact same measure as this arc on the outside. Degree measure. So, for example, if this in here is 60 degrees, what's that blue arc on the outside? 60 degrees. Okay, that's the main event of today's lesson. Now remember this, you're going to say with me, measure of the central angle to its arc the same. Say it from the top. Measure of a central angle to its arc the same. Again, measure of a central angle to its arc the same. Underline measure, right above, write the word degree. When we say the word measure, what we mean is degree. That's a central. Center. Not to be confused with inscribed. Inscribed, ready? Darken the vertex. The vertex is on the circle. This is called an inscribed. On. I'm sorry, let me get out of the fat pen here and write that a little bit more neatly. On. It's on the circle, and then the arms are in the circle. See what I mean by vertex on, arms in? That's called inscribed. So inscribed is an angle. If you were to trace it, the arms are in, but the vertex is parked on the circle. It's inscribed. See it, go to today's lesson, and you're going to get a shot at extra credit in about 5 minutes from now. Yeah, huh? Post-it notes. Where's the packet, guys? It should have been floating around. Post-it. Here's more post-it notes. Yes, ma'am? More? Yes, guys. Who still does not have their Post-it notes? Okay, there should be more around here somewhere, guys. Keep those Post-it notes going, folks. Go to the front. Here we go. Pass this over to Nadia. Thank you. Yes. Perpendicular means make a right angle. Oh, no, I haven't. I'll do that right now. Okay. Nick, lights, please. Lights, please. Let's just recap our vocabulary, and I'll give you a shot at extra credit. Ready? Step number 1. A circle is named by its center. So if I were to name this physical circle, we are now on the lesson on the front-hand side. I used a different copier. And we would call this circle G. Okay. You have a right angle there. Put a right angle there. Okay. Now that you have a right angle. That's the problem. Now, I'd like you to physically trace G to F, please. G to F. Center to edge. G to F. That is called a what, folks? That's a radius. Okay. I'd like you to trace it again. G to F. Say the word radius.
Radius.
Like a spoke in the wheel. Let's trace G to E, please. Let's trace G to D, please. Let's trace G to C, please. Let's trace G to B. The plural is radii. Radii. Okay. How many of you have ever trued or tuned a bicycle wheel before? No. Okay, so imagine it's wobbly, it means the wheel is not a perfect circle. Watch. When they are all exactly the same, when the spokes are all exactly the same, mark them. When the spokes are exactly the same, what shape do we perfectly have? Yes. And that's what's happening when you're tuning a bicycle wheel, is you're trying to make the spokes physically exactly the same so you get a perfect circle, because a perfect circle rolls perfectly. Okay? All radii are congruent. Say that.
All radii are congruent.
Remember that. Now, diameters. Remember what I want you to do with diameters? You trace them, stretch them out, and you sweep 180. That's a diameter. Okay. A chord is a segment whose endpoints are physically on the circle. So darken enough. And then over here under chord, write EF, and notice it has a segment above it. All right. Go like this with your arm. Say touch. Tangent. We're going to say touch. Tangent. Okay, so a tangent is a line that just touches the circle from the outside. Touches it at one point. That word tangent has nothing to do with the SOHCAHTOA tangent. Good old English language, exact same word, two different meanings. Yeah, just, God bless anyone who learns English as a second language. Never tease someone who tries to learn English as a second language if they're heavily accidented. Okay, English is the hardest language to learn as a second language. Are you kidding? It breaks no rule. One, our language is a hodgepodge of about, we absorb languages. Like, where do you get shun? Tion, huh? Yeah. And then what I say radii and radius. Why is it not radiuses? It's because radius is Greek, and when you go to plural, it goes to a double I. But we just taught them that. So trust me, I taught ESL guys, just have mercy. Yeah, they're there. Good luck. And then someone asks, well, why? And you're trying to teach English, and you're like, oh. Exactly. Here's case in point. Tangent. Same word, totally different meanings. Tangent is the purple. It means to touch from the outside. You guys honestly know this word.
What?
That's the way. It's like it's kind of off the topic. It kind of like, oh, so this nice circles. I just got it. That's in English. Okay, last one. Secant. Ready? I like you to physically trace B to F like this, the line, and watch BF. Oh my goodness, that looks like exactly the same thing. Okay, ready, guys? I want you to take 10 seconds and figure out, I want silence. What is the difference between the green and the orange? 10 seconds of silence.
Where?
Okay, buddy up with the neighbor. Everybody has to talk. What's the difference between the green and the orange? Go. All right, guys. Last one. Yeah, but solve for both and then turn around and check. All righty, guys. I'd like you to physically trace and sweep the arc F-E-B. Start at F. Swing around through E and end at B. That's a major arc. There is more than one name of that arc. I'm going to give you 30 seconds. I want you to write.
Oh.
I'm not saying 30 seconds to write as many different names. You got it?
Wait, what are we doing?
You are naming that red arc with different names. So you got a point there. Did you finish, Alex? Ready? Okay, you got 100%? Was that your highest score? Okay, so sign off that 13. Nice job. Shaw? Okay, time. I'll take volunteers for this one. So raise your hand if you think you have another name for that red arc. Give me one. Yes. F, D, B. I'll take it. That's excellent. Yes. Another one. Did you see? Give me another one. What? F, C, B. F, C, B. That's a good. Give me another one. FDB, yes, FDB. Yes. Yes, it is. Which one? Okay, let's check EB. Did you say EBF, ma'am? EBF, okay, so we start. Okay, watch. EBF would be the purple. Does it match the red? Okay. Any other that matches the red? Give me another one, Maddie. B, D, F going around this way, yes. B, D, F. Give me one more, yes, no. B, E, yes. B, E, F. So you guys can see that arcs can have multiple names, okay? Ready, swing into your teams, flip the page. You are now looking at teamwork problem number activity 1, okay? Swing into your teams, please. Okay, lights, please, Nick. You're going to get 2, possibly 3 shots at extra credit. Step 1, I want you to read aloud the instructions. Stop talking, go.